Welcome to this video of Ask an Engineer. Today we'll be talking about future tech. Once again, the design and social media team did not tell me what the questions are going to be, so we're going to see. Let's jump into the questions for future tech. First question, what are the future advancements in energy storage solutions, such as batteries and supercapacitors, and their implications? That's interesting. For all of these questions, since it's about future tech, there's going to be a bit of futurism here, which I read about, and the statistical likelihood of any of these answers being right is very low, but hey, I will do my best. So in terms of advancements, we're going to make the batteries a little bit better at how much they can hold, their capacity. There's the word I was looking for. But I think the biggest growth we're going to see is in longevity, both in amount of discharges that they can handle, and also just overall lifespan before they go bad. I think those are going to be some of the biggest things. Now, like many things, we might have a huge breakthrough where we find a completely new style of batteries that are better in every way. That would be absolutely wonderful. And there's been a lot of talk about solid state batteries and the increased safety and decreased weight for those solid state batteries. My understanding is that those won't have a humongous increase in terms of capacity, though. But still, lighter, safer, that would be fantastic. And that's something that they've been working on for a long time, and they've shown some good progress in recent times. Supercapacitors, the supercapacitors are pretty crazy. I heard when I was in college, somebody say, hey, if you want a supercapacitor, or not even a supercapacitor, if you want a 1 farad capacitor, it's going to be the size of one of those tank trains, like the tank things on a train. What do you call those things? Tanker cars on trains, whatever. Like they said, a 1 farad capacitor is going to be that big. And now you can go to Walmart and get like a 5 farad capacitor for your stereo system in your car so your lights don't dim when your humongous subwoofer is going crazy. But that being said, those supercapacitors aren't the same as your typical capacitors. They're that ELDC, which it's been too many years since I've looked into this in depth, electrolayer dual, oh my goodness, I don't know. But those supercapacitors are already pretty phenomenal in where they've gone in the last 20 to 40 years. So that's showing some great growth. However, supercapacitors are different from batteries. I mean, that's obvious, but the discharge profile is different and the energy density is way less than batteries, but the power density is way higher. So it depends on what you want. Now, in terms of implications, if we can get batteries that have indefinite lifespans and infinite recharge and discharge and charge cycles, then we're looking at grid level battery backups, something that we don't have to worry about replacing every 5 to 10 years at the tune of tens, if not hundreds of millions of dollars, which would be phenomenal, absolutely amazing. That's actually one of the biggest things. We've talked about it in the past. We have solar panels on my house, and I would love to get off the grid. I live out in the middle of nowhere. We have power outages all the time, just because we're so far away from things. And I would love to have battery backup, but I don't want to spend $10,000 or $20,000 on batteries that I'm going to have to replace in 7 to 10 years. I'm a cheapskate. I don't want to do that. But if I could just pay for batteries and know they were going to last my lifetime and my kids' lifetime, fantastic. That would be absolutely wonderful. So that's what I'm looking forward to. And I think that would be one of the biggest things, is not only on the grid level, but on individual levels, we would be able to have that sort of battery backup. And then, of course, being able to use those in electric vehicles would be a phenomenal boon to electric vehicles that, for all their hype, still have a lot of struggles and a lot of challenges. Supercapacitors, on the other side, are much better at things that need quick power in and out. So as we get better with those, I think we'll see more integration with those in terms of having them being used in parallel with some of those batteries for both grid and for vehicle applications and other applications, where they can work together to just give a quick shot of power when necessary. But since they're so not energy dense, because they're not energy dense, I don't think we're ever going to see those, without some massive changes, ever being used at the same scale as batteries. But used in conjunction, those two could be an amazing powerhouse that would That was a pun, I didn't mean to. But it would be an amazing powerhouse that would really revolutionize a lot of people's lives, both on a national level and on individual levels. So that's what I think. All right, let's see what other future questions we have for us. Moving on. What breakthroughs are expected in the field of solar power and other renewable energy sources? Ooh, I mean, you could have an entire paper on that. Just in solar power, they keep on talking, and they have for years now, about thin film power, or solar panels. And then they've also had a lot of changes where they've been able to increase the efficiency. They have the double-sided solar power where you can actually have light come in on one side and then light coming, like bouncing off the back and coming in. So you're getting some pretty significant increases in solar power efficiency just because it's able to collect more light. I think thin films in solar power is actually something that could be pretty phenomenal, because right now a lot of the expense is due to the fact that solar panels, they use actual silicon dioxide wafers, and it's just cut, and they do their semiconductor manufacturing on it to basically etch everything in it and have it do what you want to do. And then they create this huge panel that's all of those just basically put together and wired in series or parallel or whatever. So it's a big manufacturing cost. Whereas thin film, ideally, it literally just goes through something like it's a printer, and they just, and the cost drops a huge amount. And if they're able to do that, and they're able to get the cost reductions they're talking about, that's something where it would be absolutely phenomenal. I mean, to be completely fair, when we did our solar, the actual panels themselves were only about a third of the cost. And then the other third was basically wiring the MPPT inverters that we had, and then just other stuff made up the last third. But that being said, if you can take 1/3 of the cost of installing solar and make it 10%, that's still going to be a pretty significant thing. So I'm looking forward to just that cheaper manufacturing for solar panel. And then other renewable energy sources, honestly, I'm not aware of any off the top of my head. There's some cool stuff going on in the ocean right now with tidal and wave energy, but I'm not super familiar with those. Plus, I live inland a lot, so I don't really see such a personal interface with me, whereas solar and wind are things that I can and have looked into quite a bit because I can use them here. Okay, next question. What is the lamest IoT device you've seen? That is interesting question. I've never thought about that. The lamest IoT device. I'm going to need a moment for this. Let's see. So an IoT device is basically a device that is connected to the internet, but it's more like a wearable or something small or something integrated in here. There, it's, again, the Internet of Things. It's having objects that you wouldn't typically associate with the internet being associated with the internet. For example, we could say, like that toaster back there, if that was an IoT-enabled toaster, it's something where at work, I could say, I want toast when I get home. Push a button on Wi-Fi and it connects to it and it puts down the toast. I don't know, puts in the toast, whatever. Maybe this is a bad example, but it'd be able to toast it. And then when I get home and I pull into the garage and I go into the kitchen, I have this freshly popped toast waiting for me. And I think that'd be the lamest IoT device. Not that. That makes me think of the lamest one, I think. And that is refrigerators. I think those are dumb. Why do you have these refrigerators that are connected to the internet? I mean, I just do not see the value in it. I think they're really cool, but I also think that increases the complexity, makes it more likely that it's going to be obsolete very soon. And I hate planned obsolescence. Oh, I hate it so much. And so every time I see a refrigerator that's like, look at this, you can connect to the internet with this, and it can take pictures and tell you things like, okay, how about if I just be prepared? And before I head to the store, which for us is like almost an hour away, we look in the refrigerator and say, hey, I need these things. Now, does that bite us in the butt sometimes? Sure it does. But seriously, do I really need a refrigerator that's connected to the internet? No, that's my opinion. You're free to be completely wrong if you disagree with me. That is okay, but I think that's pretty lame. And I'm sure there's other ones, but that just popped into my head. So yeah, kitchen appliances. And even we have a sous vide machine, a Joule sous vide, and it's done through the app. There's no manual controls. That really bugs me because I'm worried that they're going to phase out the app and I'm going to be stuck with a $200 brick. So I personally, I'm old. I'm an old soul, even if I'm not that old as a person. I just think IoT devices are weird. Anyway, going on to the next question. What are the future trends in robotics and automation, and how will they affect various industries? Robotics and automation. I think there's been a lot of movement recently to robots that can interact with people, not in the way you're probably thinking that, but like you can work in them. What do they call that? Cobots, where you can be in the same space as them and they can tell where you are and can work around you. And then if they hit you, they won't just kill you and throw you out, but they'll like, oh, hey, there's an obstruction, and they're safe to work around you. They don't have to be caged. And I think that is something that is going to make a big difference, because like if you go to, for example, Volkswagen, if you go to a tour there and you look at their manufacturing, almost everything is done with robotics, and you'll have an entire floor that's almost entirely robotics. But to still have the capability of people going in amongst them and making changes or doing things without fear for their lives, literally, would be a huge benefit. So I think that from an industrial perspective, just the fact that they're making these robots smarter and safer and making it so that they can coexist with humans is going to get us a bigger integration between the benefits of automation and the benefits of a personal human touch, and really melding those together. So that's my thought in terms of robotics in manufacturing, is that we can see some real benefits there when we get the benefits of both sides of that. Okay, moving on to the next question. How will advancements in artificial intelligence and machine learning influence electrical engineering fields? This is something that we've worried a lot about recently. I'm not sure if I've come up with any good responses, but something I think about and think, I could be really in trouble if I have an AI take over my job completely. And some of the things that they're coming up with do make me a little bit nervous. It's pretty crazy. So I'm just going to put these together, artificial and machine learning, put them together at the moment. I think that used properly, artificial intelligence could be beneficial. I still think ChatGPT and its outputs, when you ask it questions, most of the time really lack the quality that I would want in something being created. I hear about people like, oh yeah, I just created this blog post with AI, and you can tell like it's still not great. But at the same time, for communication challenged engineers that really struggle to speak well and to get their thoughts out, there's a lot of good tools out there where they can say, all right, these are the things I want to say. And the AI may not do the best job, but it'll do a lot better job than they do. I think there's a lot of benefit to that. I think there could also be benefit in terms of identification of parts. On our Discord channel, I am surprised at how many times people just say, hey, I don't know what part this is, and they take a picture of it. And sometimes it's easy to look up, and other times it's really difficult to figure it out. But that's something where it would be cool to just have a AI say, oh yeah, I know exactly what that is. And I can even tell you when it was manufactured. I don't know if that'll actually be done. I'm mostly uncertain of whether or not AI is ever going to be able to make that leap to improving things. Does that make sense? Like engineering, the reason we have jobs is because we take things and we make them better, or we make something new. And AI literally, and based off of machine learning, is taking everything that's been done and is rehashing it in a way that seems human. Is that going to actually be able to create something better than the original? Is it going to be able to make intuitive leaps, things like that? I mean, this sounds like something from even a 1980s dystopian cyberpunk book or something. Like, hey, can a machine really think, like a Philip K. Dick book or something? I don't know the answer to that. But at this point, and I could be wrong in as few as a couple of days, but at this point, I think AI is not going to be able to take over engineering because it just can't think critically and it can't make intuitive leaps and can't make improvements, but it is really good at organizing. So we'll see what happens. I think we're all nervous about that one. Next question. How should electrical engineering education evolve to prepare students for future technological advancements? You know, that's interesting because I've often said that when I graduated with my degree, they had brought me up in terms of electrical engineering to like the 1930s or the 1940s in terms of technological level. So yeah, I don't know how much it really matters, because really when you come out with a bachelor's degree, you aren't at all up to the latest and greatest. You just have a good understanding of the foundation, hopefully. And then once you get to your job, you can really dive deep into the latest and greatest and really go down that channel. So I think it's not that big of a deal. I think that there's more involved in using the technology. Like, how can we in education use the current technology to teach better or to give people the tools to use? So it's not so much, hey, let's teach our students how to develop machine learning or AI or whatever, but how can we teach them to use it in an ethical and productive way that isn't just regurgitating garbage? So I think that would be more of my thought on this, is that the education shouldn't evolve to integrate the technological advancements into the curriculum so much, but use the technological advancements to enhance the teaching of that curriculum more. That's my thought. Okay, next question. How will electrical engineering intersect with other disciplines such as biotechnology, environmental science, and data science in the future? I imagine much as it does now. I mean, a lot of engineering in general is multidisciplinary. Everything touches each other now. Mechanical, electrical, civil, biomechanical, biomedical. Everything just is so integrated. I think with this one, there will be some pushes more for the efficiency on the electrical engineering side. And because on all of these, biotechnology, you want something smaller and more efficient. If that's going to be integrated into the human body or be working with the human body, you want it to be smaller and more efficient. Environmental science, we want everything to be more efficient, to produce less waste. Data science, one of the big complaints people say about artificial intelligence right now is the amount of resources it takes to use AI. They just take massive banks of computers to run. If we can make things more efficient, that'll make the data science not only more ecologically friendly, but also faster and cheaper and stuff like that. So that's kind of my viewpoint in how electrical engineering will directly affect those things. I have a feeling I'm going to wake up in the middle of the night tonight and think of something else, but right now that's all that's popping into my head. Okay, next question. What ethical considerations will become more prominent as electrical engineering technology advances? I think a lot of the ethical questions we have nowadays are more on the computer engineering, computer science, and machine science side of things, and less on the electrical engineering side. I mean, depending on what you get into, maybe on the power production side, you need to be more ethical in terms of thinking about the side effects of your power plant. Like, how is it affecting the ecosystem around it? Or if you are going back to the question about biotechnology, if you're doing something that's going to be integrated into a human body, the Neuralink thing that was done fairly recently, how is that going to be used? I've seen a lot of jokes about how that basically is going to be a new way to put Facebook ads into our brain, directly into our brain. Hopefully that is not the case. Hopefully somebody has looked at the ethics of that and said, hey, let's make this line in the sand that we're not going to cross. Big businesses, I don't know. I'm not that confident that line has been drawn. So there is some questions about how we are going to integrate into people's brains and into their bodies in general. I think there's been some other there's a lot of good sources, but like sci-fi movies out there that have talked about the development of biomedical parts that then people can't pay for, so they have to go and repossess them. I didn't see that movie, but I kind of want to. I can't remember who's in it, but somewhat recently. The Repo Man, is that it? Repo Man, something like that. Yeah, so there's some scenarios out there that science fiction writers have thought about, and they're probably a better source for this sort of question than I am. But that should be interesting. Okay, I think we're getting close to the end. Yep, one more question. What future technology or gadget are you most excited about? I'm not much of a gadget guy. I like my kitchen gadgets. I'm a kitchen gadget guy. I'm bad that way. I am a kitchen gadget guy. But other than that, I don't really like gadgets too much. So for me, it's definitely going to be future technology. And as mentioned in a previous Ask an Engineer, I am looking forward to fusion power. I think that's going to be awesome. I hope it lives up to the hype. I hope it's a reasonable cost. I hope it is able to go throughout the world at a reasonable cost and can change the lives of everybody on this planet. So that's all the questions that we had. I hope you found it interesting. If you have any comments, which I'm sure you do have thoughts and comments on this, please leave it below. I would love to see what they are. I'd love to see the discussions that happen between people as well. If you like this video, give it a like, subscribe to our channel, and we will catch you in the next one. Take care. Hey, I hope this tutorial was helpful. Did you know that CircuitBread.com also has more useful engineering content? In addition to the tutorials, textbooks, tools, and other things, we have dozens of EE FAQs that explain quick, standalone concepts that are helpful for electrical engineers. Go check them out.